team, welcome back to my channel. Thanks for stopping by. I hope you find this tutorial today very helpful. And what I decided to do is explain a little bit about how we get into mixed wireless networks, why we do that sometimes, and can we do it? Well, normally we advise, keeping everything the same. However, sometimes in a little bit more advanced applications, we have situations where we have a performance network but we need a repeater for some reason to get around a building, or maybe it's an old network that we need to, work with, or we're trying to bring all these networks together and put it into one wireless controller, for example. So first off, if you're not sure, if you don't know the differences between our wireless radio offerings, probably the one you're most familiar with is going to be the Sure Cross wireless radios. And the biggest difference here is that those can do a star topology, kind of how I have here on my screen. And you can also do, of course, the point-to-point layout. So these are very straightforward. We have specific radios that work within a performance Sure Cross. For example, all of our one-wire, all-in-one housing, those are great in the performance networks. But then we also have our multi-hop data radios, and those are a little bit more advanced. The primary difference here is going to be the tree topology. So what that means is that I can add a repeater into my network and kind of create some sort of a mesh network. And so and of course you can still do the star topology and the point-to-point on these radios, but usually we see multi-hop radios being used for outdoor, getting around a building, things like that. Another reason that we use multi-hop radio networks is for RS-45 communications. If we wanted to daisy chain a bunch of Modbus devices onto one radio, we could do that. We have specialty multi-hop radios as well, like Ethernet and serial radios. And so anyway, it's just a little bit more advanced, but it does come up, and we do have a solution to bring all of this together. So that's why I wanted to make this video. Hopefully this will help you. If you're watching this video, you're probably in this situation where you're trying to understand why or how this works. So first off, I'm going to talk about how we bring about this, and that's going to be using our banner HE5 Smart Slave board. Now, you're probably not going to find this on the website, and so if you are using this, you're probably working with a local regional sales manager that reps banners. So they can help you get the right people involved to help you get started on this. But yeah, it's just a board that you buy in addition to your bill of materials here. And this is going to have two banks of dip switches. And basically the dip switches here, all we have to do is enable it to be a repeater. And there's a little quick start guide that I can share with you on here. So that's hardware wise all you would have to buy to mix all of this together. The real bread and butter here is the network and how everything's going to be addressed and mapped. So that's kind of the tricky part. So how does this work exactly? Well, in this application, I'm just going to run through this real world application that we're working on. And for example, think of this as a network within a network. We're going to have our multi-hop radio controller at the top layer. So this is going to be controlling all of our performance networks. So these are all going to be star topology networks. In this example, I'm just going to keep it real simple, but this is a DXM 100. You can only work an HE5 Smart Slave on DXM 100s and 150s. So this will not work on a DXM 700, 1200, or 1000. So that's kind of a little gotcha there. But yeah, so what happens here, and I have a good image where it shows how the DXM is kind of made of. So it's just boards that are stacked on top of each other. So in this case, we would be removing the cellular card within the DXM and replacing that with an HE5 Smart Slave board. So once you do that, you have the dip switches set to what they need to be. You bind it to your multi-hop radio. Remember, this is a multi-hop board, and so this binds to your DXM multi-hop radio, okay? But it's within the DXM performance, so it's inside of it. And what it does is it works transparently with the performance DXM, and so it's able to share data through the same antenna, occupy that antenna, and communicate to both networks, essentially. So how do I address this, and how do I map this? That's the big question. So this right here between, and let me see if I can get my laser. So between my multi-hop and my HE5 is going to be standard binding procedure. And so this, and the way that it was explained to me and how I was taught to do this, and it makes sense to me, is by going off of an odd number for an ID. So in the multi-hop world, we start binding at node address number 11, and we can go all the way up to 110. So we can have essentially 99 radios in one multi-hop network. So I'm keeping my multi-hop network IDs, so these HE5s are going to be addressed at an odd number. The thing here is we're going to have two addresses to be working with. One is my HE5 slave ID is what we call it, and then in the performance, we're going to use what's called a Modbus slave ID, and that's different from your other network. So there's a system config submenu that you would go into and set what's called the Modbus slave ID, and I'm keeping those to an even number. So anytime I'm binding an HE5 slave board and a performance gateway, then I'm going to use two addresses. So I hope that makes sense. The way that I think it makes sense is by keeping multi-hops on an odd number, for example, and your performance networks on an even number. And keep a table, keep track of that. I like to make pictures and layouts here because that just helps me visualize how everything's going to be bound. So that's how it works. It's a very simple procedure, a standard binding here between my multi-hop, and then standard binding here between my performance network and the nodes. So here node 1 would bind standard regular binding procedure on my performance DXM. That would bind the same as we do everything. So, but the only thing I have to change is in here in the sub menu is my Modbus slave ID 12. So if I had a whole other performance DXM network, then I would set the other one to Modbus ID 14 and so forth. And another HE5 smart slave board on that one, I would do 13 for that one. So you can keep adding that way. Yeah, so this is my network. This is what I'm working with. I've got a regular node with a 4 to 20 milliamp signal coming back to my performance gateway here at a local station, and then I'm sticking that HE5 board on here and binding that over to my multi-hop network. And how do you bind the HE5 smart slave is on here. There's a little button that you would do a triple click, and yeah, so that's hopefully makes sense how it works. Now your next question is probably going to be, well, how do I do the register mapping? So I'll go ahead and do just an example of how I would map that and how I have mapped that. So let's start with a performance network, my simple, straightforward, just gateway to a node. That mapped the same way that we've mapped everything else in this channel that I've shown you. And so notice we're on a performance network, so my slave ID is always going to be 1. I'm just using one analog input, so this is a very simple mapping here. I've looked up the number. It's Modbus at register number 19, so I put that in there. And notice here, the only thing I would recommend is that's different from what I usually teach is to do this in a consecutive manner. So basically I'm copying those Modbus registers into my processor board, my local registers. I'm copying them onto that. So I want to keep everything in consecutive order. and it's going to come really handy. You don't have to, but I think it's the simplest, easiest way to go about it. So that's all I've done here. I've just created a couple registers and I've copied them over into my local register. So that's done. That's all it is. Oh, one more thing. Very important. It will not work if you do not have the wireless Modbus backbone enabled. But other than those two things, just your regular Modbus mapping and the Modbus backbone enabled, that's all this is going to be for the performance network. And then if we open up the DXM700 XML, remember you're going to have two XMLs. I'll go ahead and show you what that register mapping looks like. So we're working with multi-hop this time. So my ID, my slave ID is going to be 12, which is what we gave to the performance gateway. So that's going to be your slave ID number that you're going to fill in there. Remember, I'm just reading two registers, and my local registers on the performance network that we just made, those start at 1 and 2, and then I'm just going to copy them over into my local register. So since I did it in a consecutive addressing, I need to only create one read role. So if you've got a bunch of IO that you're bringing over, this is really important. I didn't think about this when I first did it, and so I basically had to do this twice. Wasn't a big deal, but Joe, you want to be productive with your time. And yeah, so I've copied those over here. And so I tried to label them now. I always try to label my local registers as node 1, analog input 1, and analog input 2, whatever. But in this case, I'm just calling my performance network station 1 because that's going to be its own network. So I'm trying to keep the network number and the node number into my local register. So I just remember where everything is at because I forget, if you don't look at this stuff over a year, you don't remember. But literally that is it. That's all I've done to make this work. So now all I have to do is download my XML file onto each DXM, do the binding, do the addressing on those, and you're good to go. So if you are interested in doing this or would like to see the XMLs that I've created here for this scenario, if this is a similar scenario for you, shoot me an email or a comment below and I can share these files with you. So good luck and thanks for tuning in. Hope this was helpful. I hope you have an awesome day.